Hi, hello, this is Paneer. In this video, we are going to see about pharmaceutical inorganic chemistry unit 2, that is volumetric analysis. Under this unit, we are going to cover the following contents that are volumetric analysis, definition and explanation, and solution and its types, then how to prepare a standard solution, how to set up the titration, how to do the mole calculation. Finally, one example, that is a titration of 0.1 m sodium hydroxide with HCl. What is volumetric analysis? Determination of the concentration by volume of substance in a solution as by titration. This is a definition. Volumetric analysis is a method of analysis based on titration. Then what is titration? Titration is a procedure for determining the amount of particular substance A, that is analyte, or else you can call titrant, which is present in the conical flask, by adding a carefully in a measured volume of solution with known concentration of B, that is titrant, the solution which is present in the burette, until the reaction is complete. This is the definition of titration. Now, you need to know that what is solution. A solute dissolved in a solvent. What is solute? The substance which is dissolved. What is solvent? The substance in which it is dissolved. You can see the figure here. Solvent, solute. When it mixed together, we will get the solution. The solution might be a homogeneous or heterogeneous. That we'll see in the detail about the solution. See, usually solution is made up of elements, compounds or mixtures. Once after the solution preparation, the mixture might be a homogeneous mixture or heterogeneous mixture. If it is a homogeneous mixture, in that mixture all the components has same properties. For example, cup of coffee. If it is in a heterogeneous mixture, in that mixture the components are not in a single composition. For example, oil and water. Then what is the types are there in the solution? Basis of water, non-water as a solvent. Solution classified into two types. One is aqueous solution, second one is non-aqueous solution. For aqueous solution, example is sugar or salt in a water, carbon dioxide in a water. These two examples for aqueous solution. Non-aqueous solution in the sense opposite of the aqueous solution. It means it's a non-water solvent or non-water solution. For example, phenolphthalein benzene, sulfur in carbon disulfide. These are the two examples for non-aqueous solution. Basis of an amount of solute added. We can classify the solution in three types: saturated solution, unsaturated solution, and supersaturated solution. Saturated solution in the sense reaches its limit to dissolve any more solute. Unsaturated solution in the sense still dissolve more solute in solvent. Supersaturated solution in the sense the solute is present in excess amount. What is the next type? Basis on amount of solvent added. Here again solution divided into one is a concentrated solution, other one is diluted solution. Concentrated solution in the sense large amount of solute present in the solution. Dilute solution in the sense large amount of solvent present in the solution. Next, basis of the amount of concentration of solute in two solution, we can divide solution in three types: hypertonic solution, hypotonic solution, isotonic solution. Hypertonic solution in the sense high concentration of the solute. Hypotonic solution in the sense less concentration of the solute. Isotonic solution, the same concentration of the solute in two solution. Last one is electrolytes. What is that electrolyte? Electrolyte are compounds that dissolve in a water and break into the form of ion. When break into the form of ion, can divide again the solution in two types. One is strong electrolyte, another one is weak electrolyte. Now these are all the entire detail about how we can create solution And what is the major type? Homogeneous and heterogeneous. And based on the solvent, based on the solute added, based on the solvent added, based on the concentration of the solute, based on the ion formation, these many types we can classify under types of solution. Next, you need to know that what is primary standard solution and what is the secondary standard solution. Usually the primary standard solution is having high purity around 99.9 percentage, as well that primary standard solution is having stability. In case of this secondary standard solution, you cannot found the purity and stability. For example, here you can take sodium hydroxide. Commercially, sodium hydroxide is having many impurities in it that are all sodium hydroxide, sodium chloride, sodium carbonate, sodium sulfate. These are all the impurities which is present in the sodium hydroxide. One more important thing: the sodium hydroxide can absorb the water from the atmosphere, the hygroscopic. So, to determine the concentration of sodium hydroxide in a solution, we used to titrate it against a primary standard weak acid such as potassium hydrogen thalate, hydrochloric acid, anything you can take to determine the purity of the or concentration of the sodium hydroxide. That is the reason I said that you need to know that what is primary standard solution and the secondary standard solution. What next? How to prepare a standard solution? Here I am going to explain that how to set up this volumetric analysis titration. Number one, you have to prepare a standard solution. For that, you have to weigh out the solid by using balance. Step 2, whatever you have weighed, that you mix with the water and by using glass rod. Then you transfer this prepared solution into volumetric flask. Then add distilled water about 1 centimeter below the mark of the volumetric flask. You can see here. Next, use pipette to add water dropwise up to the mark. This is the way you have to calibrate this volumetric flask. Before adding this solution into this volumetric flask, don't forget to use the stopper on the volumetric flask. So once after mixing properly the solution, you have to pipette out this solution and transfer it into conical flask. Okay, then burette has to be rinsed by using small volume of the solution of unknown. This is the way to calibrate the volumetric flask and burette. What next? Now you have solution in conical flask which is unknown concentration, and you have a solution in a burette that is a known concentration. Now in that unknown concentration in a conical flask used to called analyte or a titrant, in that you have to add 1 or 2 drops of naphthalene. After adding that indicator, you have to start your titration. Slowly add the solution to the flask from the burette while gently stirring. After some time, a pink color will appear and quickly disappear as the solution are mixed. The longer the pink color persists, the closer to the end point. This is used to called stoichiometric point. What do you mean by stoichiometric point in the sense? Stoichiometric refers to the relationship between the quantities of reactant and products before, during, and following chemical reaction. So once after reaching that end point, you have to record the burette reading. This is the way you have to set up the titration. First you have to prepare the standard solution, then you have to do the calibration of volumetric flask, and you have to calibrate the burette, then you have to perform the titration. After getting this end point, with that end point you have to calculate and you have to get the unknown solution concentration. Now What is the use of indicator in the sense? An indicator used to signal the end point. It's a highly colored dye which is shows very sharp color and change at a specific pH. Why? Because naphthalene like indicator is pH specific. Use first result as an indication, then repeat these same steps at least 3 to 5 times until the results are within 0.1 ml of each other. It means you have to perform concordant value. So to once you get that concordant value, with that concordant value, how it's matching, based on that you have to fix your final result for the unknown sample concentration. So here one more explanation. There are two types of solution you can see in the burette. One is a color solution, other one is colorless solution. If it is a colorless solution, usually it looks like concave. You can see that lower meniscus, you can see even phase boundary in the colorless solution, so that you can take even lower meniscus reading or upper meniscus reading in colorless solution. If it is a colored solution, it looks like a convex. There you cannot see any of the phase boundary. In that case, you have to take only upper meniscus reading for color solution. And other way, if you are taking titration process, you can see here titration process is having a burette solution and conical flask solution. Usually burette solution is amount of known solution. Conical flask solution is amount of unknown solution. That one used to called titrant, and conical flask solution used to call titrend. It ends with D, or else you can call analyte. So these are all the things about the titration. What next? How to calculate molarity or mole solution? This is very important because you are going to calculate the concentration. So if you need to know the concentration, you must know that how to calculate mole solution. For that, I gave an example for 1 sodium hydroxide mole solution preparation. So to prepare the mole solution, first you know the molecular weight of the sample. Here sodium hydroxide, the sample molecular weight is 40. So if I am going to prepare 1 m sodium hydroxide, then the formula is number of moles of solute divided by liter of solution. Here number of moles of solute you have to put 40 and volume 1 liter. So you will get exactly what? 40. So 40 gram in 1 liter is to called 1 m. Then if it is 0.1 m you want to prepare, then automatically weight of the solute divided by 40 into 1. If you will apply this formula, you will get that answer. The answer is 4 gram in 1 liter used to call 0.1 m sodium hydroxide. This is the way you have to calculate mole solution. What next? Example for volumetric analysis. That is titration of 0.1 m sodium hydroxide with HCl. The reaction is sodium hydroxide react with HCl. You will get H2O and sodium chloride. Here what happened? The reaction in the sense, the reaction there is a plus ion, there is a H plus ion, there is a OH minus ion. Sodium hydroxide has a OH minus and HCl has H plus. When this OH H plus meet the neutralization, you will get the pink color as a indication. So that indication indicates that the reaction is completed. That is what happened. So how to do the calculation? Here we have 0.1 m sodium hydroxide. Okay, from that if you are picking 25 ml, then the concentration 0.0025. Okay, now start doing the titration. Once after doing the titration, 24.8 ml of HCl neutralized by 25 ml of sodium hydroxide. That means the reaction ratio is 1:1. Therefore, 0.0025 mole of sodium hydroxide react with 0.0025 moles of HCl. So how to calculate the molarity of HCl? Number of moles divided by volume. If you will put 0.0025 divided by 0.0024, you will get 0.104 m. This is the way you have to calculate the concentration of the unknown unknown concentration which is present in the beaker. So this is all about what is volumetric analysis, what do you mean by solution, what are the types are there in the solution, and how to set up the standard solution, how to do the titration, and how to calculate the mole calculation, and what is the example. These many things you have to keep it in your mind and you have to write accordingly. The question comes under which category, assay type, whatever. So these are all the things you need to know in the unit volumetric analysis. I hope this video is useful. In that case, as usual, do like the video, share the video, finally subscribe my channel. Thanks for your valuable time. Thank you once again.